In this video, we're going to look at solving quadratic equations. So a quadratic equation is an equation that takes the form ax squared plus bx plus c equals 0, where a, b, and c are just numbers. So basically you have a single variable that appears with an exponent of 2 and an exponent of 1. If you have a variable like x with an exponent bigger than 2, then it's not a quadratic formula. Okay, so that just kind of lets you know that that's the type of equation the methods we're looking at will work for. So we're going to look at 4 different ways we can solve quadratic equations, starting with factoring. So this lesson is going to assume that you kind of know the basic rules for factoring. If you need a refresher course on those, then there are lots of videos on YouTube, or you can just search factoring and you'll see lots of examples of that. When we're factoring, kind of the first type of factoring that you always check for in a problem is a common factor. So to solve quadratics by factoring, you always want to get a 0 on the right side. In this case, the 0 is already on the right side, so we go straight to the factoring step. So we look at our 6x squared and our 3x and we see, do they have anything in common? Well, they both have a 3 and an x in common. A 3 will factor out and an x. So that leaves, in order to get a 6, I need a 2, right? 3 times 2 is 6, and I need another x because I only factored 1 out, minus, and then here I factored both the 3 and the x out, so that just leaves a 1 equal to 0. Once you have 2 factors, which is what we have here, 3x times 2x minus 1, so those are factors equal to 0, we can set each factor equal to 0 and solve for x, because you can only get 0 when you multiply by 0, right? So in order to have a 0 on the right side, we have 2 things multiplied together. One of those things must be 0 in order for that to be true. So we set them equal to 0. We solve for x. On this equation, we divide by 3, so we get x equals 0. Here, I'm going to add 1 to both sides, and then I'm going to divide both sides by 2. So I get 2 answers to this equation. X can be 0 or x can be 1/2. So that's how we solve by factoring. Let's look at a little different type of factoring. We could have 2x squared plus 9x plus 7 equal 3. Okay, so remember, the first step in factoring is to get a 0 over here. We do not have a 0 here, so I need to subtract 3 from both sides. So we have 2x squared plus 9x plus 4 equals 0. Now, if you remember your factoring rules, when you have an equation of this form, it'll factor into 2 parts where the first 2 numbers here are the factors of this. Well, 2 only can be, you can only get to 2 by doing 2 and 1, right? 2 times 1 is 2. So we know we're going to have a 2 and a 1, and then we have an x and an x to get to the x squared. The last 2 factors require a little bit more thought. First of all, we need to figure out if we're adding or subtracting. Well, since everything is positive, right, both of these will have to be positive. Now we have to think about the factors of 4. We want 2 numbers that will multiply to give us 4. But then when those 2 numbers are multiplied by the 1 here and the 2 here, we'll get a 9. Okay? So my choices for 4 are 2 and 2 or 4 and 1. Well, I can try, let's see, if I put a 2 here and a 2 here, then the 2 times 2x is going to give me 4x, and this is going to give me a 2x. These 2 numbers will give me 2x. Well, 4x and 2x gives me 6x. That doesn't work. I want a 9. So we know it's not 2 and 2. Now let's try 4 and 1. If I put a 4 here and a 1 here, well, when I multiply 2x and 4, I get 8x. And when I multiply x and 1, I get 1x. 8x plus 1x will give me the 9x that I need. So those are the correct factors. 2x plus 1 times x plus 4 equals 0. So now I have 2 factors multiplied together that equal 0. I can set each factor equal to 0 and solve. So I'll subtract 1 from both sides and get negative 1. Divide both sides by 2 and I get negative 1/2. For the second equation, I'm just going to subtract 4 from both sides and get x equal negative 4. So that 2 shouldn't be there, huh? When I divide by 2, this becomes just x. So those are my 2 answers to this equation. Okay, so that is solving by factoring. Next, we're going to look at solving by extracting the roots. So sometimes when you have a quadratic, you only have a single term with a variable in it. So for example, we might have something like 4x squared equals 12. In this case, because I don't have the x squared and the x, I only have the x squared, we can solve this by extracting the root. So what that means is you want to get the squared piece by itself. So you want to isolate it. So we're going to do that by dividing 4 by both sides, and we'll get x squared equals 3. Now because I have just a squared on the left, I can take the square root of both sides of this equation. The square root of x squared leaves me with x, exactly what I'm trying to get to, right? X equals something. The piece that most people forget when they're solving this way is that when you take the square root of both sides of the equation, you introduce both the positive and the negative as a potential solution, right? Because if I square a positive number and a negative number, the same positive and negative number, I get the same answer, right? The square of 3 is 9 and the square of negative 3 is 9. So you have to make sure you include that plus or minus. So really what you've got here is two answers, right? X could be the positive square root of 3, or x could be the negative square root of 3, okay? One more example of extracting the square, because you could have a whole part of the equation squared, such as this. Well, in this case, again, the square is isolated already, right? We want to get whatever is squared by itself on the left, which is the case here. So we can take the square root of both sides of this equation, and remember that introduces the plus or minus. Anytime you take the square root of both sides, you get plus or minus. So this square root and this square cancel each other to just leave x minus 3 equals plus or minus the square root of 7. And I can solve this just like any other equation. I'm going to add 3 to both sides. So I'm going to have x equals 3 plus or minus the square root of 7. Again, that's two different answers, right? X equals 3 plus the square root of 7. Or x equals 3 minus the square root of 7. Okay? The third method that we're going to look at is called completing the square. It's probably most students' least favorite method. But if you follow the steps, it's pretty straightforward. So we have x squared plus 2x minus 6 equals 0. So this is just a way to force getting a square like we had in the previous problem so that you can extract the square. So this problem actually has an x squared and an x, so we can't just isolate the square and take the square root of both sides, but if we turn it into a perfect square, we can. So the way we do that is take whatever the number is that doesn't have an x to the other side of the equation. So we're going to add 6 to both sides, and we're going to end up with this equation here. So what I want to do is add something to the left side that will make this a perfect square. But if I add it to the left, I also have to add it to the right. Okay, the way we figure out what goes in this blank is we take this middle term, and this is the process that always works. You take half of that middle term, you half it, and then you square it. So if I take half of 2, I get 1. And then if I square it, I still get 1. So that's what I need to add on the left, and then I need to add a 1 on the right. The reason we do that is because that will always factor into the square root of this, which is x, plus the square root of this, which is 1, squared. If you multiply this out, you will get this here. And that will be equal to 7. Now we have the exact same problem we had before. We have the exact same problem we had in the previous example, right? We can take the square root of both sides. So x plus 1 equals the plus or minus the square root of 7. We just take the square root of both sides. We subtract 1 from both sides. And so we get x could be negative 1 plus the square root of 7, or x could be negative 1 minus the square root of 7. Now, sometimes these problems will look like this, where this first number is not a 1. That changes slightly what we have to do, because the process that we went through here requires that you have a 1 in front of the x squared. So we just need to make this a 1 before we complete the square. So we're going to move the 3 over, just like we did previously. 2x squared plus 8x equals negative 3. Now we want to remove this 2. Well, in order to do that, we need to divide by 2. But if we're going to divide by 2 in an equation, we have to divide everything in the equation by 2. So the first term becomes x squared. This becomes 4x to the negative 3 halves. Now we can do what we did in this problem up here. We are going to take our middle term and figure out what we need to add to make it a perfect square, and then we're going to add the same thing on this side. Remember, we half it, that's 2. We square it, 2 squared is 4. So we add 4 to both sides. That's going to make this right side a perfect square. Remember, you take your first term, take the square root. This gives you the sign plus square root of the last term, 2. So that is what this factors into. Negative 3 halves plus 4, we need to get a common denominator. Well, 4 is the same thing as 8 over 2. Right? So negative 3 halves plus 8 over 2 would be 5 over 2. Now we can take the square root of both sides. If I take the square root of both sides, I'm going to have plus or minus the square root of 5 halves. I'm going to subtract 2 from both sides, and I'm going to get negative 2 plus or minus. This is the same thing as the square root of 5 over the square root of 2. So when we are writing our final answer, we never want a square root in the denominator. The way we get rid of a square root in the denominator is we multiply by the denominator exactly as is, but then we also have to multiply the numerator by it. So this becomes negative 2 plus or minus the square root of 5 times the square root of 2 is the square root of 10. The square root of 2 times the square root of 2 is 2. So that got rid of our square root in the denominator, which is exactly what we were trying to do. So x equals this. All right, one more method for solving quadratics is called the quadratic formula. Now, the truth is the quadratic formula will solve any quadratic equation always. It always works. So factoring sometimes works. Completing the square sometimes works. Extracting the root sometimes works. Completing the square you probably could always do, but sometimes the numbers get really, really complex and tedious when you have a lot of fractions. So it's not always the easiest to use, but the quadratic formula can always be used. So if you have a quadratic equation such as this, right, it is true that x is always equal to, when you solve it, negative b plus or minus the square root of b squared minus 4ac over 2a. So a, b, and c are just the numbers in each term, the coefficients as they're called. So if we have an equation x squared plus 3x equals 9, we can solve this using the quadratic formula. The key thing you have to remember before you put it in the quadratic formula is you have to have a 0 on the right, just like with factoring. So we need to subtract 9 from both sides to get 0. So remember that the number here is our a, which in this case is a 1. The number here is b, and the number here is c. So we look at our formula. Right? And we have x equals negative b, our b is 3, so that's negative 3, plus or minus the square root of b squared, so 3 squared, minus 4, a is 1, c is negative 9, all over 2 times a, which again is 1. Now it's just a matter of simplifying. Negative 3 plus or minus the square root, 3 squared is 9, minus 4 times 1 is minus 4, times minus 9 is plus 36 over 2. So x equals negative 3 plus or minus the square root of 45 over 2. The square root of 45 will simplify because 45 is the same thing as 9 times 5. So x is negative 3 plus or minus the square root of 9 is 3. That leaves the 5 under the square root over 2. So this is your final answer.